Hello everyone, welcome to the week 5 recording for game design. And you can see that week 5 is the gameplay unit. I'll go ahead into the announcements. And here we are at week 5. And as a reminder, before we jump into that, remember I have this announcement called assignment directions where I post some helpful videos, like shorter videos to help you with the work. So if you're having trouble with the work or you get a low score, please take a look at those directions. Those can really help you, those videos. All right, week 5. Week 5, we have, of course, the Class Connect write-up as always. We also have what's called the finishing plan, and we'll look at that shortly. The finishing plan is an opportunity for you to earn some points by figuring out how you're going to pass the class. We're halfway through the class, so it's a good time for you to kind of collect your thoughts and figure out what you need to do to get the grade you want. So looking into this unit, of course, you're going to skip the discussion. We skipped all the discussions. You have a storyboard assignment that I'll cover. Then you have a rules quiz, only one quiz in this unit. Then in section B, you have an assignment on implementation of game mechanics. So that's all the work you have for this week. Fairly short week, so if you have old work, you can get that made up, I'm sure. So I'm going to close that, and we'll slide on down here and go into the week 5 Class Connect write-up. Actually, before we do that, we want to look at the finishing plan. So I talked about the finishing plan, and you can see the finishing plan is pretty simple, but you need to make sure you read the questions carefully and answer them completely. Some questions I ask for points and others I ask for grade percent. You will not get to revise this work. This is worth 25 points, so I suggest that you take your time on answering these questions. There are really no right or wrong answers unless you, because it's all, well, there are right or wrong answers, but I mean, I'm not going to be checking on the answers, but just follow the questions and pay attention to what I want, and you'll get 100% on these. Now, a thing to remember, this class is worth 1,000 points, so the math is easy, right? So if you have 795 points, or if you want 79.5%, which is going to be a B, then you need 795 points. If you just want to pass, which is 59.5, which is a D, then you need 595. So I think you can figure that out. So you're going to submit these as text in the Dropbox, not as an attachment. You're going to do these just like you do the write-ups. So you copy this whole thing, paste it into a word processor, answer the questions, then copy everything and paste it in the Dropbox. So let's take a look here. What is your current grade percentage and points earned? So I want you to tell me, obviously, your grade percentage and points earned. There's going to be different things. If this is what you did up here, your grade percentage would be 79.5, your points earned would be 795. So pretty basic, pretty easy question. What grade percentage do you want? If you want to get 98% in this class, then your grade percentage will be 98%. If you want to get 69.5, so you get a C, then 69.5% is your grade percent that you want. So just tell me what grade percent you want in this class. Don't tell me the points in question number 2. Question number 2, I'm asking you the grade percent. How many more points do you need to get to the grade percent you want? So let's say right now you have 320 points and you want to get 79.5%. That would mean you'd want 795 points. So you'd need to get 795 minus 320, which would be 475 more points, right? So this is going to take a little bit of math, but I hope you could figure it out based on the grade percent you have now will tell you how many points you have right now. And then then you need to figure out how many points you want overall. And then just do a little bit of math to figure out how many more points you need to earn. How many more days are there in this block, which ends on October 11th? So block ends on October 11th. Depending on when you do this finishing plan, you're going to need to figure out the number of days until October 11th. Include weekdays and weekends, because weekends are times when you can work also, right? And that's what the point is here. This means I want you to think of how many days of work there are possibly left. Okay, number 5. List 5 assignments and include the points possible for each one you'll complete before October 11. So you can look at the work for this week. I'll also post the work for next week and the subsequent weeks, so you can easily go in and see what the work is. You could also, probably the easier way to do this, we just go to the gradebook and see what all the assignments are in the gradebook. Even if we haven't gotten to them, the assignments are still there, and the assignments have the points with them. So the idea here, of course, is that you need to list 5 assignments and the points possible for each of those assignments. Then finally, how many hours per week do you plan to put in through October 11th? Well, we have, let me pull up a calendar here. We have 1 week, 2 weeks, 3 weeks, 4 weeks. We have 5 weeks left. So how many hours per week do you plan to put in for those 5 weeks, for each of those 5 weeks? So these questions are pretty straightforward, pretty basic. Just think about them before you turn your answers in. Again, you cannot revise this, just get a one shot at this, because I think it's simple enough that you should be able to get it. If you have any questions about it, send me an email, a K-mail, and I'll help you out with that a little bit. All right, let's jump into this. So the Week 5 Class Connect write-up. So here we are, 5 questions for Section A, 5 for Section B. So Section A, what do the terms game mechanics and gameplay describe? What is one big challenge in game mechanics? What is the most important factor in the degree of interactivity in gameplay? How are simple and fuzzy logic different? Explain what a prototype storyboard is. All right, let's go into Section A. So now we get into game mechanics and rules of games. So in this section, you're going to look at game mechanics and how rules shape games. We're going to analyze game constraints and look at the reasoning behind gameplay rules. So game mechanics and gameplay, they are terms used to describe the process that constitute different elements of interactivity in a game. So that's the answer to that first Class Connect write-up. Those are what game mechanics and gameplay are. They describe the process that constitute different elements of interactivity in games. And this talks about in games you have what are called agents, and these are the characters or elements in a game which are a challenge to you. So it could be a person, a thing to overcome, whatever it happens to be, but those are called game agents. And any game can be considered a controlled chaotic environment. Chaotic means crazy, because all the interactive elements are subject to different combinations, right? So in different games, in some games at least, depending on the choices you make, then the game could change as you go along. Here's a little bit of information about artificial intelligence. You can either play up here or you can just read it down below. So in early generations of games, like in Pac-Man, those are just simple mathematic algorithms. So depending on where you move your Pac-Man control item, then Pac-Man would change, because there were preset combinations, and the game would change based on exactly what you did, and then the game would cause you to do something else. And then for some reason this talks about playing with dolls and things like that. I have no idea why it really talks about that. But now, I guess because when we were kids we played with dolls and they really kept us spellbound. But now we use games that keep us spellbound, right? And of course games have to be much more challenging in order for us to be really engaged in them. And artificial intelligence came along. And this is where they really started figuring out, well, how can we really make games fantastic and sweep users off their feet and just make games crazy and engage users. And that's what they're trying to do with games, using artificial intelligence rather than just old mathematic formulas. So a little bit about gameplay. This talks, as you watch a movie, you see facial expressions, body language of the actors, things like that. They let you know about different emotions that are running on in the game or in the movie. And then it talks about if an actor playing Julius Caesar recites Iutu Brute, in a pre-recorded answering machine message, nobody would ever, it's not engaging, right? That's because our minds are accustomed to reality. We have to have auditory and visual clues. So that's what we need to get to. And the biggest challenge that game designers have today, the game mechanics of today, the greatest challenge is to make games as realistic as possible. So that was that second write-up question. One big challenge of game mechanics is to make the games as realistic as possible. So some gameplay constraints. Artificial intelligence come a long way just being able to design characters who are awake to agents who are aware of gameplay and which is in progress. And what that means is that different components of the game are actually almost thinking, and they determine what they're going to do based on the plays that you make. So with artificial intelligence, it says down here, they don't just rely on the game player's reflexes, but also they rely on strategy and the elements of stealth or the elements of surprise and things like that. So games are almost thinking certainly more than they used to, but not really thinking in the way that we think about what thinking is, using your mind. But games can adapt to users, can't they? So as AI grows, the equipment needed to handle it becomes much greater. So that's one reason a lot of people use computers, PCs, rather than consoles, because PCs, as we learned, the technology is much better on PCs. Gameplay reasoning rules. Let's go back to the write-up. See what our questions are. What is the most important factor in the degree of interactivity in gameplay? But this doesn't have that answer, but I just want to go through this. This talks about game mechanics, and game mechanics defines the rules. And you're going to be writing some rules for your game this week, so you need to learn about what this is. So there's many different types of reasoning rules in games. There's turn-based rules, like Mario Brothers. So first player's turn, second player's turn, so it depends on whose turn it is, and the gameplay will move along at that, right? In some games there are action points, which are features of the game. And when a person gets that action point, then certain things happen. There's auction or bidding involves the player's discretion. A player you can buy different components or different tools or new weapons and things like that. Some games are random, and like card games, casino games, they have probability is a huge factor in that kind of game. There's capture or elimination games, where you capture or eliminate an agent to proceed in the game. So that could be that you could solve a problem, then move on, or if you get rid of one of the other players, then you can move on. And then the catch-up gaming rule is just where you're trying to urge people to move on in the game. So you have goals that makes the people just want to continue pursuing the game and pursuing the goals in the game. So think about rules and how different rules might play into the game that you're designing. A little quiz on game mechanics and rules. So game mechanics and rules. Again, we're talking about that still. So gameplay rules control the gamer the moment he assumes the role of the character. So as soon as somebody turns the game on, the rules you have created, and I don't mean rules by you have to do this, have to do that, but the rules are the way the game is played. But those rules are what the character uses to navigate throughout the game, right? And the gameplay environment is built around the characters, and the characters are the building blocks of the game. And there are different types of role-playing in games. There's single and multiplayer. So while gameplay rules in a single-player mode are designed for player versus artificial intelligence, multiplayer mode features that's much more complex, isn't it? Because you play against other players, you could play against artificial intelligence, all kinds of things. but gameplay rules are the most important factor in the degree of interactivity in the game. That's Class Connect Right Up answer. Gameplay rules are the most important factor in the degree of interactivity in a game. That's actually answer to number 3 right here. Okay, so moving ahead. As we start to look at different rules in games, the ultimate purpose of gameplay rules is to achieve a specific goal. So the rules that you create in your game allow persuade the player to move on and achieve goals and keep going on in the game, right? So as a player plays different types of games, they encounter different types of rules. So here are different categories of rules. So loss avoidance. The infliction of damage by the agents in the game on the player has to be minimized, right? So what this means is if you're playing an army type game or a shoot 'em up game, you don't want to get shot, right? So that's loss avoidance. Puzzle guessing. Games such as Scrabble and chess require cognitive thinking, cause you to use your mind. And these follow a system called fuzzy logic. Fuzzy logic gives a large array of different combinations of choices, and we'll talk more about that in a minute. Then rules in racing. So in racing games, they can seem to be pretty basic, as this talks about right here. Because their goals, of course, is to get past the finish line before somebody else to score the most points. But they're much more complex than just crossing the finish line. If you've ever played Need for Speed, you see that there are many different challenges that you would have for as a game player. Territory control, so strategy games where you want to take over different territories and such. And that would be the primary objective, is to capture new territories. Then finally, structure building, so you can see like a Tetris type game. So there are different rules that you play in the Tetris game in order to build the structures that you want. Okay, fuzzy logic and simple logic. Well, in the old days, regular logic, basic logic was yes or no, meaning 0 or 1, false and true. So false, true, yes, no. So simple logic, the choices are yes, no. So like, some games that are, if you're playing the game and you choose to go through a certain door, then one thing's going to happen to you. If you choose to go through another door, something else is going to happen to you. Those are just yes, no, depending on the choice that you make. But fuzzy logic is different. Fuzzy logic isn't true or false, but kind of a degree of true or false. So simple logic has a bunch of rules, yes or no. Fuzzy logic has a range of values. So if we look down here for our answer, this talks about a thermostat, like a thermostat in your house. If you want the temperature, if your thermostat would only let you do 30 or 40 degrees and nothing in between, that would be like simple logic, right? Yes, it's 40. No, it's not 40, it's 30. But your thermostat actually lets you put it at 30.1, 30.2, 30.3, etc. So that would be fuzzy logic, right? You have lots of choices in between. So if you look down here, simple logic gives the player just 2 outcomes. Fuzzy logic gives lots of variable outcomes, depending on how the player is playing it. So this is the answer for that question about simple logic and fuzzy logic. Here's the discussion. We're skipping all the discussions again. Playtesting and prototyping. Now, a game is just like a movie. A movie production, when they're first starting it, what's called the pre-production phase. That's all the initial planning. They write the script, they determine their cast or the actors, they get their crew together, and all of that, right? Well, game development has the same thing, and it's called prototyping. And a prototype game, it's sometimes called a storyboard or a storyboard prototype, but this is a sequence of drawings that show the levels of the game and different scenes or goals of the game. So that's a storyboard. So what I would suggest you do is do a search online, because you have a storyboard assignment later. Do a search for storyboard to find out more about what a storyboard is. But a storyboard, there are sketches that kind of give different scenes of the game. So as it talks about here, game developers start by conceptualizing the game elements and try to implement it with their team to analyze the concept of the game. Most prototypes today are digital ones with graphics, and the game mechanics are built right into the ideas of the storyboarding. Some game developers prefer the analog prototypes, and that means cutting out characters and cardboard cutouts and different things like that. But most of them do it with digital. Now, your work with storyboard work this week, you'll be doing with pen and pencil, or you can do it, I mean, if you're good enough with graphic design software, you can do that. Again, play testing and physical prototyping. This is talking about a game called Secret Paths, which kids are given paper dolls that represent animals, plants, etc., and they have to write a play about them. Just kind of a little kids game. And the kids imagine a storyline and they create the characters and things like that. So as they start doing this, the final project reflects what the kids wanted, the elements of nature and different things like that. So that gives you an idea of how you take the different features of what your game is, and then you build on them for what you want the game to be. And when you do prototyping is done a lot so you can get feedback before you start the actual computerized part of designing the game, the computer programming and things like that, because that's the most expensive part. So they don't want to have a lousy prototype and then they go in and build the game on a lousy prototype. They need to have a really high quality prototype before they do it. And this all talks about that idea how with bad prototyping that's going to be a waste of time. Okay, this is a storyboard assignment. So you're going to choose an older game, one that's not too complicated. So it could be a simple game, a 10-year-old type of a game or something like that, and something that I'd be able to understand, so kid friendly. But you're going to play the game, take some notes on it, then you're going to do this. I would suggest you do it in a PowerPoint or other presentation software. And you're going to do the general rules, the characters, the environment, the goals, progression levels, etc. And you'll sketch out the characters and the environment. Don't copy and paste images from the web. I'll do a more in-depth explanation of this later, but that's the storyboard assignment. The rules of prototyping, this is just a little drag and drop activity for you. And finally the rules quiz, and the rules quiz is over here. And then there's the rules quiz preview. There's only one quiz in this unit, so that's good, isn't it? All right, let's move on to section B. So section B, let's look at the write-up first. So in a game, what do levels provide? So that's the first idea for section B. So here we are in section B. So levels are the basic building blocks of a game. But what levels do is levels provide harder challenges as the gameplay progresses. So you all know that, right? When you get to different levels in a game, it gets much more difficult. The competition is tougher. If it's a racing game, the cars are faster, different things like that, right? So that's what levels provide. They provide harder challenges as the game progresses. And in this section, we're going to learn about level designing and understanding different level techniques. So this is the tutorial on level designing. And I'm going to go back to the write-up because all of these last 7, these are all from this level designing tutorial. So what does each and every level in a game have? How are plot and level transition related? What are some factors that can determine the level's duration? Explain what nonlinear levels are. So we're going to go right in here, and you could listen to it or you could read it. So I'm just going to go over this. So this starts talking about complex concepts can be broken down into smaller pieces, right? Smaller fragments. And that's a really important thing to think about. You need to break your game down, especially the different goals and objectives, the different components of it, break it down into smaller pieces. Makes it much easier for people to understand. Now in games, each and every level has a set of objectives or goals that have to be accomplished. So that was that write-up question. That was that answer right there. What does each and every level in a game have? So we just talked about that. So after the accomplishment of the level goals, then the gameplay continues to the next level. You all know that from different games that you've played, right? Game developers may even create hidden rooms or areas that you have to have additional rewards to get into. And players should be rewarded for achieving these extra goals, just like students get extra credit in some classes. So think about that when you start designing the different levels for your game. Different levels may have different goals, so you can proceed to help you proceed with the gameplay, right? Some of the aspects necessitate the need for the flow in the game levels, which is obtained by the usage of color schemes, music. So the game levels really have to all flow together. What this talks about right here says the transitions from one level to another, so transitions from moving to one level to another, are important so that the plot continues seamlessly from level to level. So that's how transitions and plot are related. The transitions have to flow seamlessly as people go from level to level. So the plot is the game, right? And then the transitions have to flow seamlessly within the plot as people go from level to level. So that's the answer to this one. Are plot and level transitions related? This starts talking about the duration of games, the duration of different levels. And there are some different factors: difficulty level, the importance of the level in the plot of the whole game, and the phase of the plot in which the level occurs. And what part of the game did the level occur? And those can affect the duration. So those are three things that can affect the duration of games, of levels. And some console games might run 45 minutes per level, while some hardcore games might be 2 hours per level. Really depends. So that's the answer to that third Class Connect write-up question in this section, where some factors determine levels duration. As we get down, it starts talking more about time, and we've talked already about real time and how real time, the gameplay acts like real time, although it's faster than time in our real lives, but things happen as if they were in real life time. Physical environment of the game, that's called the space of the game, and it can be map with rooms, tunnels, hills, etc. It can even just be the playing field if it's a soccer game or a basketball court or something like that. So that's called the space of a game. And some games have different levels with different camera angles. So in some games, if you get to certain levels, you maybe gain different camera angles. A first-person shooter, of course, is your almost always first-person shooter, but some you can go out to a different camera angle and see what the environment you're in. Now, gamers sometimes, or developers, they exaggerate virtual reality because that makes the game really dynamic, really engaging, and interesting to players. And games don't always have to go from level to level. Some games can go from one level back to an old level and then up to a different level. So there are really different ways that games can progress. So you can kind of read through this and learn about how levels progress. And finally, modern games, they've gone away from linear levels, which mean right in a row, 1, 2, 3, 4, 5, right in a row, and they've gone into non-linear levels. And what non-linear levels do is the games branch out in different combinations depending on the gameplay. So that's what non-linear means. So depending on how you play the game, you might have different options than the way somebody else has to play the game. So that's what non-linear means, that you just don't go in straight lines essentially from area to every area or level to level. So we talked about non-linear there. All right. So we went through that. Just a couple more things. We'll wrap this up. Drag and drop activity for you. And then there's a gameplay, a practical activity. They want you to play this game and then kind of write a detail about the gameplay structure. Go ahead and do this then, and here's the chart to look at somewhere. I don't know if that chart is going to want to open up for me. It says it's opening, but I can't see where it's open. So you can look at that chart. Now you're not going to submit this assignment, but you can look here to find the answers. But give this a try just to think about it. I mean, maybe play it for 10 minutes and just think about the gameplay structure of that. Now the last thing for this unit is implementation of game mechanics. This is where you're going to work on creating a storyboard for the game that you've been working on all along. So remember earlier you did the storyboard for a simple type game. Now you're going to storyboard your own game. And I'll create a separate recording for this. But one thing to think about, you're going to draw your own characters and environments. You should have a different slide for each level. Some people might have 2 slides for each level. And you need to have some notes about what are some of the goals of the level, the sound effects, the music, and narration. Think about some of those things for your game. Yeah, I'll create a separate recording for this, but that can at least give you an idea of the work you're going to be doing for that. So that's all I have for week 5. So go back here, week 5. We've talked about all of these things. You have the write-up to submit, the finishing plan to submit, quiz to submit, storyboard, and finally game mechanics assignment. So 5 things to do this week. And if you have extra time, get old work submitted. All right, thanks everybody. I look forward to your work coming in. Bye.